Hi, my name's Samuel Findlay, and you're listening to the ACES podcast. In today's episode, I chat with Dr Amy Gelmi, who is the Vice Chancellor's Research Fellow at RMIT. Amy studied a PhD at the University of Wollongong before moving to Sweden and then London to further her career before a move to Melbourne, where she now finds herself. We spoke about her journey in research, her current work, and much more. So let's get to the podcast conversation. So I'm chatting to Dr. Amy Gelmi on the ACES podcast today. Thanks for joining me, Amy.
Thanks for having me, Sam.
It's a pleasure. How are you? We were just chatting before I hit record that the restrictions have eased off slightly. You're based down in Melbourne. How have things this year's obviously been very different for you, especially for researchers. How's things?
Yeah, no, it's been a bit of a crazy year, for sure, but things are getting back to normal, I think, as of today. We're on the 6th day of 0-0, so I hope by the time people are listening, maybe we've made it out 2 weeks without any community transmission. That would be amazing. But yeah, this year's just been kind of weird because it's just a lot more focus on supporting my research students and trying to keep them excited about research, and we can't even get into the lab, and excited about what we're going to do. So there's a lot of career development and not a lot of original research, but a lot of review writing.
So when was the last time you went into the labs?
So I was in the lab during stage 4, which was a bit tricky because there were such heavy restrictions on how long you could be in for. I was only approved for 2 days a week. So it was more just checking in and maintaining some cell cultures and helping one of my PhD students, keeping him up to date and trained while we waited for more access to come up. But I think the last time I probably did an actual experiment based on my projects was probably in March.
Wow.
I think because we did start a few things when between the 2 lockdowns down in Melbourne, we did get some stuff up and running, but we didn't really get the chance to finish it. And a lot of it was just still foundation work with the stem cells, because I knew that the chance of us getting locked down again could be quite high. So it was just really minimizing expensive reagent use that may not result in any good results. Because we did a lot of we cultured quite a few stem cells that we were going to do some image analysis with, and they end up sitting in the fridge for a few months, and unfortunately, it's not very useful data at the end of the day by the time we get to image them.
So lots of paper writing this year?
Yes, yeah. I was lucky enough that I actually had an invited review before the pandemic hit, so that was a good time to finish it up. So it kind of came out a bit earlier. So that was really nice. That's in Advanced Healthcare Materials, if anyone wants to check it out.
Oh, great.
A little plug for myself, bioresponsive, stimulus responsive biomaterials. So it was written with a colleague that I was at Imperial College London with. And so she's now based in Oregon and Portland. So we actually came up with the idea for the review on a boat trip in Corfu that we were in Greece for a friend's wedding.
Oh, wow.
From the lab. So we're like, we should write a review together. And then another friend, she works as an editor at one of the Wiley journals. So she said, that sounds great. Submit the idea and we'll put you on the list and we'll reach out if we're interested. And they did. So that's how you get reviews. You just got to take a boat trip with some colleagues and journal editors.
Some advice for PhD students now for when they can travel again.
Yeah, that was a bit sad. The review came out. It's like, I remember where this all started, and we were traveling so much, and now we can't. But hopefully next year.
Yeah, fingers crossed. Speaking about being able to travel again and life, I guess before COVID. Let's go back to your PhD experience. That was at the University of Wollongong, correct?
Yes, that's right. Yep, at IPRI, Intelligent Polymer Research Institute.
So what did you do for your PhD?
Yeah, so I worked with Michael Higgins and obviously Gordon Wallace, and the aim of my general PhD project was investigating biomolecular dopants in conductive polymer biomaterials. So we did a lot of atomic force microscopy to investigate kind of down on the nano scale on how different biomolecular dopants, so ones that you might generally find in the body. So, for example, hyaluronic acid, chondroitin sulfate, as well as some non-biological dopants, how they affected the structure of polypyrrole, a conductive polymer, and how that might then influence cellular interactions. Because a lot of people in the field at the time were kind of publishing work saying, oh yeah, if we put a biomolecular dopant in, it makes it more biocompatible. But without a lot of evidence to kind of say that it was actually the biological component of that dopant was making that big effect. And so we investigated things like the physical properties, because when you start incorporating different dopants, you actually change the material properties quite a lot, and trying to understand if the cells could really sense these biological components within the conductive polymer material. And so the kind of answer was, for some, yes, and for some, no. And in the end, the physical material properties would have a greater effect than the biological components that were kind of presented in the material. So it was really interesting, and we did a lot of, like I said, atomic force microscopy to kind of investigate down on that kind of subcellular level to see what was going on there.
And you stayed on as a research assistant after finishing your PhD?
Yeah, for a little bit while I was looking for postdocs. So we were working on kind of similar stuff, like looking at graphene on different polymer substrates, and looking at how we could stimulate nerve cells on that. And again, I was kind of more on the material property characterization side of that little project, which was really nice.
So when did you sort of realize that you wanted to do a PhD? Was it something that you always had a plan to do when you started your bachelor? Or was it something that evolved over time?
It's a good question. I think I remember I chose my bachelor, which was it was a Bachelor of Science in Nanotechnology at Curtin University in Perth. And I chose it because I couldn't decide between chemistry and physics, because I like them both. And I just I think I spent the first couple of years just happily doing undergraduate courses and not really thinking too much about it. And then I think by the time I reached my third year, I had the marks to do honours. So I was pretty keen to do an honours project. And I think it was that summer between third and fourth year, I did a summer internship with one of the researchers there. So they were much more heavily like inorganic chemistry in the faculty there. And I did my honours project, which was actually on controlling tin oxide nanoparticle growth. So it was very different to what I do now.
Yeah.
Very different. And it was honestly during my honours I realised that, this actually really, I like this a lot, being in the lab and getting to kind of choose the experiments that I want to do and designing them how I want to do them with my supervisor. And I would say it was my fourth year that I was really like, actually I think I do want to do a PhD. That'd be pretty cool. Because I wasn't honestly that aware of what career paths were out there with a bachelor's. Like I knew I didn't want to just go and work as a lab tech. For example, I didn't want to go, like in Western Australia, it's very common to go up and work in the mines as well, especially if you have a chemistry degree. It's really quite easy to get a good job up there, but I wasn't super keen on that. I was really drawn to the idea of a PhD because what I truly love, what I really love to do is problem solve and learn new things. And the thought of kind of perpetuating, continuing to learn, continuing to kind of do new stuff was very exciting to me. And so I was like, I can keep doing that for another 3 years. I should do that and see how it goes. So yeah, I would say it was pretty late in the game that I decided to do a PhD, I guess. But, it was quite good. I contacted a few labs around Australia who did nanotechnology, and IPRI was one of them. And yeah, they chatted with Gordon, and they flew me over to check out the labs and have a chat with people. And they said, we've got PhDs in bionics, and I think at the time they might have called it like the solar cell research, like the energy materials research. Like, what are you interested in? I said, bionics, that sounds pretty cool. And that's what happened. I kind of flew back a few months later to start a PhD project, which I didn't really know much about, except it was going to be on biomaterials and bionics with Michael. So yeah, it was a bit of a whirlwind, but it was quite exciting and turned out to be a very good decision.
So are you originally from Perth?
No, I'm from a town called Esperance, which is about 8 hours drive from Perth, down on the southwest coast. It's beautiful. It's got the best beaches in the world. And that's why when people are like, Wollongong beaches are so good. Well, they're okay.
Yeah.
Esperance is better. But it's very remote. The water's very cold and there are a lot of sharks.
Okay.
But it is beautiful.
Maybe that's why the beaches are better here, because we might have less sharks.
Oh, but you guys have jellyfish, and that weirds me out.
Well, that's true. So after spending that time at the University of Wollongong, your first postdoctoral position was overseas. Is that correct?
Yes, that's right. Yeah. So I was at Linköping University with Edwin Yaga. So he is a common, well, he's a common collaborator. He's a collaborator with Ivry quite a lot. I met him quite a few times over my PhD. So he does sabbaticals occasionally in Australia. He would come over. So he does a lot of soft robotics and conductive polymers for actuators. So he's very much on the material side, but he had a project that was about, it was in collaboration with a researcher at the hospital campus of the University of Linköping. And it was looking at creating cardiac patch scaffolds using conductive polymers. So there's an electrical and mechanical stimulus of stem cells to induce cardiac differentiation. And so that kind of caught my eye, because I did find working on the more bio aspect of the materials really interesting, but I hadn't had any experience working firsthand with the cells. It was more about proteins and characterization. And so I was really keen to learn a new skill set and kind of keep moving further into that bio area. So I saw I think Jeff Spinks actually emailed it around the group that Edwin was looking for a postdoc researcher, and I applied and sent in my details and my answers to the job application questions. And then 2 weeks later, I got it, and I was moving to Sweden. So that was
Wow.
again, it happened all very quickly, to be honest. But I think Edwin was very keen to get somebody from IFRI, because he knew that we had that
Sure.
bio side of our materials research. So yeah.
And you spent a few years there?
Yeah, so it ended up being just over, or almost 2.5 years, like between 2.5 years in the end. It was really nice. Like Linköping is more of a college town, so it's about 2 hours from Stockholm.
Right.
We rode our bikes to work every day. It was about 50 minutes ride. It was all very nature and outdoorsy. It was quite nice. The lab, again, it was a biosensors aspect to the lab as well, and bioelectronics. So they were much more, again, materials based or actuator based research, and I was kind of the only person working on the bio side. So chatting a lot with the collaborators up at the hospital was quite useful. So there was a postdoc there, Arturo, who was really great. So he worked with induced pluripotent stem cells, which is what we ended up working with. And so they're a very cool stem cell line, very tricky to work with. So he was excellent to work with. And we got a couple of nice papers out of that, because we did actually end up creating a scaffold that stimulated induced pluripotent stem cells to generate cardiac markers. So that was really exciting in the end,
Yeah, great.
Took the 2 years to kind of develop and get it working, but we did get there, and it was a really nice little project that we developed there.
And then on to Imperial College in London?
Yeah, that's right. So I knew working on that project kind of really sealed for me that I did like the bio aspect of being more on the bio aspect of biomaterials. But what was kind of frustrating me a lot from my own background and skill set and from reading papers is that the field at the time seemed very divided into either it was materials people doing a little bit of biological research, or biologists doing a tiny bit of materials research, and there wasn't a lot of overlap. And there seemed to be this real disconnect in trying to understand how the stem cells were actually kind of transducing the signals from the materials in a meaningful way. So you'd get materials people growing cells, and they might use like fibroblasts or something simple cell line and do live dead assay, like say whether the cells lived or died after a few days. And if they did, that's cool, publish. And then you would get biologists doing really cool biology where they're looking at more like gene expression and tracking changes, intracellular changes of the cells and how they're really responding and what mechanisms are undergoing. But they would do it on very simple materials like Gelma or any of the other kind of more commercial polymer lines that don't really do anything. They're just kind of like a passive material. So I was really keen to kind of move more into the understanding how the cells respond to their biomaterial environment, and especially on biomaterials which we can induce changes in. So responsive biomaterials like conductive polymers that you can electrically stimulate, for example. And I'd approached Molly Stevens at a conference. I'd emailed her before, the conference, sent her an email and said I was interested in postdoctoral opportunities. Met up with her at a conference that we were both at, and we had a chat, and it was quite productive chat. And so she invited me to come and have a lab tour and talk to her postdocs and PhDs within the lab. And from there, I applied for an Marie Curie fellowship with her, which is a European funding grant for early career researchers. And so it's a 2-year funding that pays your salary and gives you a bit of money for research. But the stipulation is you must move from one country to another to do it. So because I was in Sweden, I could apply for the European style of the grant, where I was moving from one European country to another.
Right.
So the UK was still in Europe at that point. And so, so I moved from Sweden to the UK with that grant. So that was really exciting. It's a really fantastic grant to get. It's quite similar to the DECRA in Australia,
right?
A little bit shorter.
Okay.
With 2 years, and so I moved to Molly's lab, and that's where I started doing work on kind of understanding single cell response to electrical stimulus, to try to understand the mechanisms that drive stem cell differentiation with electrical stimulus, because it's not really well known. It's still not really well known. We made a dent, though, I think, in starting to understand what was going on, and that's a lot of what I'm continuing on here down at RMIT.
So how did those research experience differ, sort of starting in Australia for your PhD, and then, spending a bit of time as a research assistant, then over to Europe, to Sweden, and then to London? Were they very different?
They were and they weren't, kind of. I mean, it was quite interesting that the IPRI and Molly's lab they're both very big labs. So IPRI is obviously like a really big institute where you've got multiple areas of research and quite a lot of researchers in a big kind of self-contained lab. And at Molly's lab, she had about, at the time, it was 35 PhDs, 35 postdocs, which was really big for a UK group. And we pretty much had a big lab at the Imperial College campus to ourselves. And we worked in very diverse areas. So there was, again, they did biosensors, there was nanoparticle research, organic synthesis, hardcore biology, biomaterials, tissue engineering. There was nanomaterial development. So it was a really diverse group of researchers in both labs, I'd say, in Wollongong and Imperial, with Imperial kind of a bit more focused on the bio. So it was a really good place to learn these skills. That's where I actually learned how to do cell culture and learned a lot more about the bio aspect of what I wanted to do. But compared to Sweden, which was a much smaller lab, there was maybe 10 people. So
right.
It was much more like having to go look outside for support for the collaborations with the biological research. And I think definitely Wollongong and Imperial really enforced to me that I prefer to work in very multidisciplinary labs. And that's why I try to build my lab up in RMIT, because I think you get a lot more out of it if you have people you've got engineers and scientists from different aspects. So material scientists, chemical scientists, biological scientists, bioengineers, mechanical engineers. Like if you've got this spread of expertise, you can do some really interesting science instead of kind of being locked down one specific niche. It does make it tricky because sometimes you feel like you're just a jack of all trades, master of none. There's definitely a feeling I have a lot, but to kind of overcome that, I just try to foster a lot of relationships with people who I think are experts in the field. And work with them and collaborate with them. So it's like, I have this idea. I think we could combine this with that. Do you think it'll work? And they're like, oh, that's a bit crazy, but yeah, maybe we could try this. And so that's kind of the way I really like to work, is just surrounding myself with a really diverse, like both diverse in like a research background and diverse in cultural background as well, because I feel like if you have people who've learned if they've done their education in different environments, you do get different problem solving approaches to things. And so it's not just about having a diverse, like, I've got an engineer or a scientist. It's about people who have diverse ways of thinking, because perhaps culturally they think about things differently. And so you get, I think, a much better problem solving approach when you've got lots of different viewpoints coming together to a problem, even if it is like a simple engineering problem you're trying to solve.
Yeah. So after your time at Imperial College in London, you moved back to Australia, and now you're at RMIT University as a Vice Chancellor's Research Fellow. How did that opportunity come about?
That was, so I was in the UK, and I was really keen to move back to Australia. The plan always was to spend about 5 years, the early career researcher phase, overseas and get a lot of international experience, which worked out. And so I think it was actually 4 years ago, which I remember because of certain world events. I was in the cusp of preparing job interview slides and seminar for a position I didn't get, but it was back in Melbourne. So I was flown back to Melbourne for that. That was my first job interview back in Australia. So over 18 months, I probably applied for 4 independent research positions. So not postdocs, not even primary lecturing positions, but ones where I would be primarily research and have my own lab. And so there's not a lot of those jobs around, unfortunately, at the moment. And I also had applied for a DECRA in that time. And so those 4 jobs and the DECRA, I got absolutely slammed in the DECRA. I don't think I've ever had a lower ranked grant in my life. They hated me. It was terrible. So anyone listening, if you write a grant and you get absolutely slammed, don't worry. Because the next year I applied, after I actually got the position at RMIT, and my CV had not changed at all. The project had changed, and the institute that I'd applied with had changed, but I had not changed. And I went from being ranked in the bottom 10% to being ranked in the top 10%. I still didn't get the DECRA, but it was amazing the difference.
Yeah, wow. Resilience.
In response to me. So I was like, well, at least I feel a bit better now.
Yeah.
But yeah, so I applied for these 4 jobs, and I got interviews for 3, and I got one of them. So the RMIT, they didn't fly a server, but it was all online, so Skype interview, which was about 4 a.m. in the morning, which was delightful. And at the time, I was in my first trimester with my first kid, and so it was really fun waking up with morning sickness to sell myself to a panel of people over video. But apparently, I did a very good job, so that worked out. So it was the Vice Chancellor's fellowships. They're really nice. They're a 4-year fellowship with research money allocated for every year. And so there's a lot of support for us to develop our research platforms within the research priorities of the university. And there's a lot of support to help you kind of set yourself up and reach out and connect with other people across the university. So very trying to encourage a lot of that cross-discipline research as well, which is really nice. And so far it was going really great for the first year, and then COVID hit. So that was put a damper on things, but I feel very privileged that I've got a position that I've still got a couple of years left to go. I'm not freaking out about what I'm going to do afterwards. The 4-year fellowship as well, assuming that I perform up to task, I will be offered a continuing position. So that's a really nice bit of security to have in the current research climate. And to follow on from that, the second unsuccessful DECRA, I took that research, the science from that project, I turned it into a discovery project and popped on collaborator Kate Fox, who's in engineering here at RMIT, and we were successful. So it was my first time applying for a discovery project. I'm level B currently. So pretty junior, and it was just Kate on it as well, she's a level D, so an associate professor. And it was my first time applying for a discovery project, and I was successful. And I think,
great.
Sometimes I'm like, wow, I don't really know how that happens. So, you can be, some grants will fall through and you won't get them, and sometimes they'll pop up when you least expect it. Because I just kind of turned it into a discovery with the idea of, this will be a good learning experience. I'll be able to see the comments and make it better next year. I'll just pop it in for now and see what happens. And we actually got it. So that was amazing. That's really kind of cemented a lot of the research that I'm trying to do at RMIT.
Yeah. So, you sort of touched on the position there, but I guess what's the main focus of your research in that position?
Yeah. So I'm trying, my research group focuses on developing external platforms for stem cell stimulus. So we're developing, part of it is engineering new devices to externally stimulate stem cells. So that could be, it is electrical and or mechanical stimulus, so stretch and strain. Electrical, we do field and direct stimulation like via electrodes. And I also do a bit of collaboration with people who have other external stimulus platforms, such as surface wave acoustics with Professor Leslie Yeo, who's at RMIT, and some other 2D material stimulus as well with some people at University of Melbourne that we've just started looking at. And the idea is that we want to investigate how stem cells respond to these external stimulus that are delivered kind of through like energy stimulation. So I said electrical stimulation or applying a stress or a strain. The mechanical stimulus is a bit better understood, but we want to see how that works in collaboration with electrical stimulus because we're quite interested to see how that goes. And the idea is basically to see if we can use this electrical or external stimulus to drive specific stem cell differentiation with the idea that we can build some platforms for individual tissue engineering therapies. So the idea that you could take stem cells from a patient, treat them, condition them with our stimulus that will direct them towards the targeted tissue type, which might, for example, be bone, it might be muscle, it might be cardiac tissue, depending on what that patient needs. Condition the cells, train the cells to grow into that cell type, and then collect the cells and either implant them back into the patient or implant them into some kind of tissue engineering scaffold to be implanted back, that kind of, that's down the track, like how we get it back into the patient. It's not so much
sure.
what we're doing, but we're trying to see if we can kind of have really understand how these different external stimuli drive stem cell behavior and how we can harness that to treat patients on an individual level, because stem cells respond really differently depending on where they come from. So a person who's probably from an older demographic, their stem cells behave very differently to a young person, for example. And so it's like, well, how do the stem cells like from different donors respond? That's the first question that we're asking. And can we come up with kind of global effects, like things that doesn't matter where that stem cell comes from, we can definitely get them to behave a certain way? Or is this something that we're going to have to tailor patient to patient? And so part of understanding how we can tailor that, we're developing these stimulation platforms that are high throughput so that we can test lots of different stimulation parameters within a single experiment and try to understand what's going on.
Sounds really exciting.
I think so, and I really want to get in the lab and get it going. We've been developing some prototypes throughout the year. That's mostly what we've been doing in the lockdown. So I've had an engineering capstone student who's done a lot of design work in SolidWorks and using ComSol for simulations. And then we've got a master's student as well who actually has a 3D printer at home. So he's been printing some devices to start testing out. So we've kind of got a couple of prototypes to get going with. But the idea is that we can upscale it hopefully in the next few months to full-scaled prototypes with that 48 wells instead of the 8 that we've started with. And really get cracking on this, because the high throughput research area in general in science is really fascinating, starting to move away from that slow kind of manual labor that comes a lot hand in hand with biological science. The idea that we can start generating a lot of outputs over short periods of time and then using also our computational analysis, so automated computational analysis, to tell us what's going on rather than manually looking at each cell or doing really long-term differentiation. If we can shorten that a lot by having algorithms or even machine learning to kind of identify which simulations are having an effect and which aren't, is really exciting. There's a lot of fantastic work being done in the high throughput platform area in general across biology. At the moment, there's some really great stuff being done with like organoid development, like creating high throughput platforms for organoids for looking at drug screening, for example. It's like really cool stuff.
Yeah.
So I'm like, why can't we apply it to electrical stimulus?
Why not?
Why not? And so that was my question. Someone said, oh, we can. I said, great, let's do it.
So something I've continued to ask everyone on the podcast, and it might be a little bit hard for you to answer because of the circumstances down in Melbourne, but is there maybe a morning routine, or it doesn't necessarily have to be a morning routine, but maybe something that you sort of do every day that helps you approach your day and approach your work?
Definitely coffee is up there.
I hear that.
Honestly, the work from home routine at the moment is driving my toddler into daycare, coming home and walking to get a coffee from the coffee shop around the corner and just having a bit of a walk outside. It's been the start of the routine. But I would say, honestly, this year, working from home has also really helped me sort out my online organizational skills. So I had started to set it up prior to the pandemic, but now it's it's nice. Like I use OneNote, for example. So our RMIT uses the Microsoft Office kind of suite of programs, and so we've got OneNote, which is really handy because now I've got things like all my student plans and research projects. It's easy for me and my students to see and monitor. So I have to-do lists, and we've got our where we're going with our projects and where we're at, and we have teams where we discuss and can keep in touch with everything that's going on, even though we can't be seeing each other in person, which helps a lot. So, and then using SharePoint and things and being organized about everything that we've got in the lab. So I think I'm very much a list maker. So I'd say that's primarily the way that I kind of start my day, is checking out what my list says for the month, and then it's usually categorized into priority, and I get to it, I guess, that way, because otherwise you feel a bit aimless when you're working from home. So definitely need a bit of structure and go-to points.
Definitely. And just to wrap up the podcast, I was wondering if you might be able to offer any advice to maybe current PhD students or those who are maybe thinking about embarking on a PhD.
In this current climate, it's tricky, because my number one advice to PhD students is make sure that you travel. It's definitely, like, networking is a big part of science, and it's not a bad part. Like I'm definitely an introvert. I'm someone who, I'm totally fine chatting with people, going to a conference, talking, but then I need to go and sit in a quiet room for a little while afterwards. But going to conferences, reaching out to, especially if you're coming to the end of the PhD and you want to do a postdoc, look at the labs who are doing work that you think is exciting and reach out to those professors. Email them, especially if you can meet up with them at a conference. Again, it's tricky right now, but who knows, maybe next year we can start doing that again, or they may even be quite keen to have a chat over Zoom or Skype or whatever video software that you prefer to use. And reaching out in a way that shows that you are specifically interested in their lab, especially coming out to the end of the PhD as well, thinking about where you might want to go. So I often tell PhD students, like, you're really not limited to what you did your PhD in. Like, you should use your postdoc time as time to kind of reach out and branch out to other skill sets and other projects that you might be interested in. Because I went from, like I said, like a conductive polymer biomaterials and electrochemistry to tissue engineering, like actually doing cell culture. So and I've never taken a biology class in my life. So it's just about thinking about what skill sets you want to what skill sets you want to use and learn, and targeting groups that do that. And definitely it's the same, I'd give the same advice to someone looking for a postdoc and a PhD, is choose your supervisor, not the project, because you can change a project you don't like. You can always rejig it, you can always refocus it. It's a lot more difficult if you don't mesh with the supervisor. It's a lot more difficult if you just don't have the same communication style with your supervisor, or you just don't get along, or maybe they're not as present, or they're not as flexible as you'd hoped. So even if the project looks amazing, like, oh my God, I love it so much, but I'm not getting a great vibe from the prof, don't go with it. If you find a good supervisor, then usually they can help you tailor the project to what you're interested in and what you want to learn. And definitely shop around is a funny word. Like, obviously in this research climate, we're all like desperate to get positions and move on, but you can be a little picky. And really think about what's best for you and what you want to do with your PhD, with your postdoc. And I chat a lot with other ECRs and colleagues especially from Imperial. We're all moving kind of into this stage of independent researchers. And I remember after my very first job interview, the one which happened 4 years ago, I came back, and I obviously didn't get the position, but it was such a really good learning experience. It was like kind of the first time I really had to sit down and think about what I wanted to do. Like, I could think about a lot of interesting research projects, but I couldn't conceptualize what I wanted my lab to look like, and a 5-year plan for my lab, and what would my PhD projects look like, and what if I had a postdoc, what would they be doing? And it was so hard thinking about that when you are a postdoc. But that kind of really triggered in me that I had to think about that, and I sat down. It probably took me 6 months to really develop and solidify where I wanted to go, and okay, this is what my lab looks like. This is what it'll be. And even then it changed a lot after I got to RMIT and learned more about what facilities they had and the expertise around me. And so now I kind of look down, I'm like, oh, actually, I could list off 5 or 6 PhD projects off the top of my head if I had the students to do it.
Yeah.
And so it's sitting down and thinking about where you want to be is really hard, but it's really worth it. And you don't have to think 5 years ahead. Like, even if it's just like, in the next couple of years, I'd really love to learn how to do this technique or how to kind of be an expert in this part of the field, and kind of push yourself towards that rather than just being like, oh, well, I guess I got this postdoc's kind of the same as what I did before, but it's the first one. I better just take that and I'll see what happens. You can take time to really think about what's going to benefit you in your career and where do you want to go. And even if that's not academia, like, where can I work that's going to start introducing me to industry links? Where can I work where I'm going to understand how to run a startup? Like, for the very first time in my life, I'm getting involved with writing up some IP applications. I'm like, it might not go up. I just need to figure out how to do this because I've never done it before.
Yeah.
So I guess be your own advocate, and it's definitely worth the time to do a bit of self-reflection and think about what's going to benefit you. Be a bit selfish. What's going to benefit you? Have a real good think about it. And if you don't know, that's also totally fine, because we don't always know.
Fantastic advice. Be your own advocate. I like that. Well, that brings us to the end of the podcast. Thanks so much for your time, Amy. It's been a pleasure to chat with you.
Thanks, Sam. Thanks for inviting me on. It's always good to waffle on about what I get up to. So it's great.
Thanks for listening to the ACES podcast. For more episodes like this one, be sure to subscribe wherever it is you get your podcasts. You can also find more information about ACES on our website, electromaterials.edu.au. There you'll find links to our various social media platforms. And you can also follow me on Twitter @Samuel Findlay. Until next time, thanks for listening.